Welcome to the early birds. We're just getting set up, so grab a coffee, invite a friend, or feel free to ask me questions in this pre-chat whilst folk join. We'll formally kick off the show at 9 AM Pacific time. I see some of you are already there in the chat, so feel free to say hi to each other and let us know where you're from and what your experience with machine learning and Tensorflow Js is to get things started. Hello there, Greece. Good to see you in the chat. It's always good to see a very international audience. And Texas as well. Great stuff. Nice to see you, Royce. And of course, Grant Laborde is in the chat. He's one of our ML GDEs and the author of a very special book that we'll actually be giving away today. So stay tuned to learn more about that later on. I'm also curious to hear from you if you've already been using Tensorflow Js. Let us know in the chat what projects you've made or maybe what you're thinking of making after the show. Love to hear from you on those matters as well. Hello, South America. Welcome to the show. Great to have you with us. Awesome. I see someone's already using Grant's book. That's great to see. Grant will be very happy to see that. How are you finding it so far? Welcome, India. I'd love to see everyone from India as well. Always regulars in the show, so thank you for joining today. I know the time might be a bit antisocial for you, so thank you very much for being here. Now, whilst you're waiting, remember there's the Made with TFJS hashtag that you can use on Twitter and LinkedIn if you make something cool. And of course, after today's show, there's even more inspiration to be seen over there. There's loads of people using the hashtag all the time, so remember to check that out after the show. I'll put some links in the chat now so you can use those later as well. Welcome Ivory Coast and Tunisia. Great to have you on the show as well. Thanks for joining. And I see you're using PWAs there. Nice one. It's really cool to be using those. They can work offline, of course, which is awesome and give you that native-like feel. And of course, TensorFlow Js can run in those. So that's great to see. Do tag me in what you make. I'd love to see what you're creating there. And if you're using Python models right now, remember you can use our command line converter to convert them into TensorFlow JS format that you can use in the browser. And on that note, if you're looking to go from 0 to hero in TensorFlow JS, I've got a brand new course on edX that's free to take. I'm going to post the link in the chat now for you to bookmark for later, and that will allow you to learn how to do all of the things I just said. So feel free to use this link to learn about that. There you go. If you're just joining, I see there's now 40 people watching. Welcome to the show. I'm Jason Mays, your host for today. And I'd love to hear where you're from and your experience with machine learning, just to kind of warm things up. We'll be kicking off at 9 AM. So of course, feel free to wait until then, grab a coffee, invite a friend, all that good stuff. But in the meantime, get to know each other. Our community is really friendly, and I'd love to see what people have been up to since last time. You're welcome, Diver. I'm glad you're enjoying the show. And remember to smash those subscribe and like buttons if you're new, so you get notified next time we go live. We do this every 3 months to get the community together. So do subscribe and hit like so everyone gets notified. Hello Bangalore, welcome to the live chat. We'll be starting in about 25 minutes or so feel free to enjoy and ask questions in the meantime. Also, if you are new to Tensorflow Js, I'll put some links in the chat right now, which are useful for you to bookmark for later as well. Feel free to open them in a new tab. This is the Tensorflow Js website. And if you're interested in the pre-made models you can use out of the box in just a few lines of JavaScript, here's another link for you. And of course, if you want to ask more in-depth questions after the show with our software engineers, we can actually host you over on our Tensorflow Js forum as well. Now, for those of you who just joined, we're going to be doing a book giveaway later in the show today by our author Gartner Board. He's a GDE with machine learning here at Google, and he's published a book with O'Reilly, and we'll be telling you how you can potentially win a signed copy of that very shortly. So stay tuned for more details. Welcome Jen Person to the live chat. I'm very pleased to announce I now have another developer relations engineer on the team joining me on TensorFlow JS. So please give Jen a warm welcome in the chat. And of course, we love to see emojis. So please feel free to smash those emojis if you can hear me. We love to see those emojis throughout the show to give people support. So get ready to use those later on. Nice one, Grant. Always the first to respond to such things. Thank you very much. And hello there, Joo. Joo is actually one of our presenters today. So remember, our presenters are also in the live chat, hopefully. So feel free to ask questions throughout the show. It's not just me here. We've got our presenters in the live chat who can answer questions as you watch their videos. So remember to do that too. And I'm glad, Jen, you found the emojis. Good stuff. And thank you, Joo, for also joining in. And everyone, excellent. Good stuff. We got the emojis going. Excellent. Welcome to all the new folk. We're at 42 people right now. Hopefully we'll make it to 100 by the time we actually kick off. You are early at the moment, so this is the pre-chat. Feel free to ask me questions or tell me what you've been up to in TensorFlow JS. It's always great to hear what people are doing. Or maybe if you're new to TensorFlow JS, tell us what you want to do in the future. Maybe you've got some project idea in mind. This is a great place to find like-minded folk to hack with in the future as well. Welcome Mexico, great to have you in the chat. We've got a very international community today. I think we've got Greece, India, Mexico, and many, many others. So looking forward to meeting you all after the show. And yes, the super resolution is pretty cool. In fact, today we have the author of that in live with us to talk about that. So stay tuned for a more in-depth interview with him. And remember, whilst you're waiting, you can connect with me on social media as well. I'm going to put my links in the live chat right now. Feel free to connect with me on Twitter, LinkedIn, or even Discord if you prefer. And we can keep in touch after the show because, of course, all the great questions always come afterwards. So feel free to add me there so we can keep in touch for later on. So TensorFlow JS, if you're running in the browser, will work on any device with a browser. That includes mobile phones. So I see a question around that right there. Obviously, performance will vary depending on the phone that you're executing on. but it should work in Chrome or Safari or all the mobile versions of the browsers, Firefox and so on and so forth, on mobile phones as well. So feel free to try those out. You can try any of our pre-made models over on the phones to kind of get a feel for the speed you can get. I believe many of our new pre-made models can run at over 60 frames per second on a modern phone, so that's pretty good if you're trying to do pose estimation, body segmentation, and that kind of thing. And yes, it is a cool microphone. I always get one comment about the RGB in my room. I love all my RGB. Obviously, it makes the machine learning models train much faster. And there might be a little secret message for you in my backpack later on that you'll see when we go live. So look out for the backpack that has even more LEDs for your viewing pleasure. Remember, if you just joined, feel free to tell us where you're from and your experience with machine learning. It's always great to hear from first timers or experienced people. So do let us know a little bit about you. And if you're looking for someone to hack with, feel free to tell us about your projects, because you never know who's in the live chat. We've got some very experienced developers with us here today. We've got some engineers from Google, and of course, developer relations is also in the chat today as well. So do feel free to give us a shout out with what you're making. I see Jorge actually has something that's featured in the media. That's awesome. In British media. Was that the BBC by any chance? Excellent. I think I saw something on the BBC Click recently, which was from Team Sports Pro, I believe. They were actually on our show 3 months ago. Are you working for them or with them? And congratulations on that, by the way. It's a really big achievement. And yes, if you do follow me on Twitter, you'll see the follow account go up live behind me right here. And of course, if you smash subscribe, we have a lot of subscribers on the YouTube channel, so we need at least 1,000 to see any difference on my counter there. But that might be harder to achieve. But yes, if you follow me on Twitter, you'll see it come up on the screen there. Always good fun to see. So today you're going to be learning about how machine learning can be used in web apps. And that can actually extend anywhere JavaScript can run. So you'll see later on today, we even can use it with hardware. We've got an animatronic backpack that can actually talk, which is really, really cool. And Ian Charnas, who made that, will be talking about that later on. So today is more of an inspiration session. If you want to learn how to go from zero to hero with web machine learning and Tensorflow Js, you can take my online course over on edX for free, and I'll put the link right now in the chat for you to bookmark for later. So if you're feeling inspired by anything you see today, go take that course and then you'll be able to create that too. So fun fact, I see a question about TypeScript. Actually, Tensorflow Js is written in TypeScript and then of course compiled down to JavaScript. So if you are interested in looking at TypeScript kind of code, check out our GitHub repository, which I'll put in the chat in just a second. And you can actually go through all of that over there if you so desire. You might need to change the build rules if you want to get a TypeScript build going for yourself, but feel free to connect with me after the show and we can talk to you about how to do that. So I see there you're asking about Danfo.js, I believe is what you mean. Danfo.js is essentially a replica of Pandas in JavaScript. So now that JavaScript is taking off with machine learning, we're starting to see the community port many of the popular libraries and tooling that Python had into the JavaScript community. So Danfo.js essentially replicates pandas to allow you to use all the tooling that you are used to from Python in JavaScript. So do check that out. If you want demos on that, you can follow the creators over on Twitter. I'll try and find their details and send them over in the chat for you to follow. They're really friendly folk, so feel free to ask them questions as well. I see more people have joined. If you're new right now, we are in the pre-show chat, so feel free to ask questions, introduce yourself, say hello to your fellow community. It's always great to see what people are up to. And of course, let me know if you've got any questions about Tensorflow Js whilst you're waiting. And Gant seems to have added a Danfo.js chapter as well in his book, so that's really great. Do check that out. And of course, we've got a chance to win Gant's book, a signed copy, very rare. He is live in the chat, and basically we'll be giving out a book later on in the show, so stay tuned to learn how you can have a chance to win that. And on that note, we'll be having a Google Hangout at the end of the show, which is private and not recorded, where you can ask questions live to me and the community in a more private setting, which is not recorded. So feel free to stay to the very end for that, where we can all get together and have a good chat. A great question there about machine learning models for sports. Actually, there's some companies that are working in this area, such as Team Sports Pro from the UK. They've been using our body pose estimation models to understand the pose estimation of a human body, which allows them to gamify sports routines and so on and so forth. So we have seen people start to do that. We've also seen people make kind of camera tracking utilities for sports to keep the person in the center of the camera frame using hardware and Tensorflow Js. In fact, that was our first ever Kickstarter. So that's pretty cool. And we're starting to see more things come out from startups pretty much every other week. So things are really growing right now in that space, but it's still many areas where you can grow and create new things as well. So if you've got an idea, you might actually be first to market. So this is a great time to get started with Web MLv and use it in a novel way. But to answer your question specifically, I've not seen one for cricket yet. So maybe you want to make one for cricket to automatically keep count of various things or understand the performance of the sports players and that kind of thing. What did you have in mind? And remember, we love to see emojis in the live chat. So even if you just want to send some fire right now, make everything get warmed up in the live chat whilst we're waiting, that's great to see. I love to see those emojis when people are presenting, especially to kind of show your love for what you're seeing on the screen. So make sure you do that throughout the show and show your support for whoever is presenting throughout the show. Remember, if you've just joined, you can ask us questions live right now. We are actually live, and this is the pre-chat, so anything is welcome around Tensorflow Js. Feel free to ask right now in this private time that we have. And we've also got time after the show in our Hangout, which I'll give a link to later on. Awesome. So yeah, if you make that cricket detection model, do let me know. I'd love to see that in action. Maybe you'll be on our future show if you manage to create that. That'd be great to see. And on that note, if you are looking to get on the show in the future, if you've made something novel that solves a problem in the real world, remember to use the Made with TFJS hashtag on Twitter and LinkedIn in order for a chance for us to find you and invite you to the show in the future. I see Juan there has used TensorFlow with a convolutional neural network to identify plant diseases. That's really cool. Actually, I was an AI mentor to a company, a non-profit organization over in India. I think they're called Wadwani.ai, who are doing similar things for crop pest detection over in the fields in India to know when to spray the fertilizers and all this kind of stuff. So very useful stuff. I'd love to see your demo if you've got one. Feel free to tag me on Twitter or LinkedIn so I can see that in action. That sounds awesome. Welcome, Hugo. Hugo is another one of our machine learning GDEs, Google Developer Experts for Tensorflow JS and beyond. Welcome to the chat, Hugo. Great to have you with us all the way from Brazil. So I see a question around how to make Snapchat lenses using TensorFlow Js. I'm not sure what technology Snapchat uses. If they are using JavaScript, then technically it should be possible. And you can use many of our body pose estimation models, body segmentation, face understanding, hand pose estimation models, to do some really great augmented reality style effects for things like Snapchat. I believe we're even used in WeChat and other things, if I remember correctly. So it should be possible if you can run JavaScript. You can use TensorFlow JS there. Oh, there's a big horn going outside. Hopefully you can't hear that. What is my favorite project so far? That is a hard question to answer. Honestly, there's so much great content out there. I don't think I can pick a favorite. I personally am interested in generative models, things that are like GANs and autoencoders. In fact, today we'll see an autoencoder in action. And if you check out my previous show and tell recordings, you'll learn a lot more about what autoencoders are and how they can be used to generate faces or whatever it might be. So I'm very interested in that area, as I think it's kind of cool to see the effects. And we're starting to see some of that stuff come out in JavaScript. But honestly, every day I think I've seen everything and something new comes out, and there's always something that goes beyond my expectations. So if you've got ideas, do make them. I love to see what everyone creates. You're a very creative community, and I'd love to see more stuff coming out from all of you over there. I see a question from Grant there. I'd love to see TensorFlow JS applied to noise cancellation. Maybe or maybe not. We might have some research in there. I cannot confirm anything, but it's definitely possible. So yes, I think it's definitely doable. And if you've got the right training data and so on and so forth, you can do things like that live with TensorFlow JS. I see a question there, how to implement TensorFlow JS and Opengl for Flutter web plugins. Unfortunately, I'm not familiar with Flutter. However, I believe it should be possible to integrate with Flutter. I'm actually planning to reach out to the Flutter team at Google. So if that's something that's interesting to you, maybe we can do a collaboration with Flutter in the future for all of you interested in Flutter. So please send some love for Flutter in the live chat if you'd be interested in something like that for a tutorial on how to use TensorFlow JS with Flutter. Oh, thank you so much. Yes, my invisibility... so not invisibility cloak, the clothes fitting project is something I made 2 years ago. So for anyone who hasn't seen that yet, essentially I used a body segmentation model to understand how I can estimate the size of clothing at the checkout for a clothing website. I don't know about you, but I'm really terrible at picking the right size clothing for different brands and so on and so forth. So I figured I'd solve this problem with TensorFlow JS, and that's really cool because in under 15 seconds at checkout, it can then automatically select for you the small, medium or large t-shirt without you having to measure yourself manually. And of course, different brands have different sizes for different people. So the brand could customize that to their needs and make sure the user gets the best experience possible, which of course means less returns and more productivity for the user as well. So win-win all around. So yes, if you've got a problem in your life that you want to solve, consider using TensorFlow JS for it if appropriate, and I'd love to see those results shared with us in the Made with TFJS hashtag on Twitter and LinkedIn for a chance to be on our future shows. So I see a question there around if you need to know Python or just JavaScript. The good answer, if you are a JavaScript developer, which 70% of developers are, is with TensorFlow JS, you just need to know JavaScript. That's the beauty of TensorFlow JS. It's written for JavaScript developers and Node.js developers. So do check out my course if you want to learn more about that. In fact, I'll put the course link in the show right now so you can see that. If you take this course, which is free over on edX, you can learn everything you need to know to make your own custom models, how to retrain models, and even convert things from Python to JavaScript if you want to get stuff that might not be currently in JavaScript over to the web. So I think someone's asking about if we could integrate TensorFlow JS with Webgl maybe. So actually Webgl is one of TensorFlow JS backends, and by backend here I don't mean server side, I mean the kind of hardware execution. So WebGL allows GPU execution in the browser. So we actually use graphics to do mathematics in the case of machine learning. And WebGL is one of the technologies we use to get the high performance that you'll see in many of the demos today. So for example, some of our pose estimation models or body segmentation models on a NVIDIA 1070 graphics card, which is not even current generation technology, it's quite old now, can run at over 150 to 200 frames per second in a modern web browser on desktop or laptop, for example. So really powerful stuff. And yes, WebGL is already being used, and we're actually investigating Web GPU as well in the future to enhance all the backends that we can run on to get even faster performance. Now we've got about 5 minutes to go before we kick off the show, so this is your last chance to grab a coffee, invite a friend, and all that fun stuff. We'll be kicking off the show in just a few minutes' time. So get settled in and get ready with those emoji buttons for when the show kicks off. I want to see the chat flooded with all those emojis. And remember to like and subscribe if this is your first time here. We do this every 3 months, so don't miss the future shows by clicking like and subscribe. So I see a question there around updating Node.js. Great question. Actually, I've been talking to Jen about this in the chat about having an update to Node right now. So if you've got specific recommendations or thoughts there, let Jen know in the chat and she can take note of that and make sure we pass it back to the software engineering team here at Google. But yes, we are maintaining Node, and of course there are updates coming out all the time, but if there's something specific you want, do let us know if something's missing and we can look into that for you. So I see a question there about how to warm up a model and not block the page UI. Well, actually at Google I/O this year, we launched a brand new feature in Tensorflow Js, if you're using the latest version of Tensorflow Js, that allows you to actually load models without blocking the UI automatically. So you get that for free these days. It's actually basically is around using WebGL for parallel compilation, a bit of a mouthful, but if Nali is in the chat, she can tell you more about that, one of our software engineers who actually works on this. But essentially that problem is now solved. In fact, as long as you're using the latest version of Tensorflow JS on the client side in the browser, you shouldn't get any blocking issues if you're executing on the WebGL backend. Now, if you want to warm up your model, you can just simply pass zeros through the model at the very beginning. So you can do tf.zeros of the right tensor shape, pass that through the model, and you can then warm up the model in advance so it's ready to go when you actually need to use it. But the actual act of loading the model doesn't cause a UI block anymore. So that is actually solved, and if you just upgrade, you'll get that for free. Cool, so we've got just over a minute to go. I'm going to start getting ready for the live show in just a few seconds, so feel free to chat among yourselves for now. And of course, I'll have more time later on to answer questions as they come in, so feel free to answer them throughout the show. And I hope you enjoy the show, everyone. Thank you so much for being here today. Please invite a friend. This is your last chance to do that. The more the merrier. It's a really great community, and I hope to see you all in the future as well. So feel free to hit like and subscribe. And of course, we'll do this every 3 months. So let's get ready, and I'll see you in just a few seconds. Welcome everyone to the 7th Tensorflow Js Show and Tell. We've got 6 new demos for you today, some new announcements, and another O'Reilly book giveaway thanks to our GDE Gartner board, who's with us live in the chat. So if you want a chance to win that book, ask questions throughout the live stream to our wonderful presenters, send your love in the live chat, and join our Hangout after the show where we'll select the winner. Now, as always, it's great seeing many familiar names in the live chat, so welcome back to the regulars. This community really is special, so thank you so much for being part of it here on the Tensorflow YouTube channel. And for those of you joining for the first time, smash those like and subscribe buttons so you don't miss future sessions. Now, it's not too late to invite a friend. The number of people using Tensorflow Js has grown exponentially since 2020 when we first started this show. And I'd love to see more folk getting to know each other, as it's a great way to take your first steps and find someone to hack with. In fact, if you've got a project idea that you could use Tensorflow Js for, let us know in the comments below so people can find you and help you out. Now, for those of you who are new to the show, I'm Jason Mays, Developer Relations Engineer for Web ML here at Google. And remember, this is a live stream, so feel free to ask me questions in the chat and I'll try and go through as many as I can. Today, we've got something for everyone, no matter what your background, but if you're new to TensorFlow JS, consider checking out my brand new edX course that's free to take and will enable you to go from zero to hero in WebML with TensorFlow JS. Even better, no background in machine learning is required to take this course, just a willingness to learn and a familiarity with JavaScript, CSS, and HTML. I'll put the link in the live chat shortly and in the description for those joining afterwards. Now, without further ado, today we have 6 new demos built by folk in the TensorFlow JS community from all around the world. And it should be noted that many of the presenters today are live with us in the YouTube chat too, so do feel free to ask questions as you watch the show or just cheer them on in the live chat, as we love to see those emojis. As always, links and demos and further reading will be in the description of the YouTube video after the show, so do check those out to learn more and of course to try the demos for yourself later. Also, to keep in line with tradition, for those of you who want to continue to nerd out, we'll have a smaller Google Hangout at the end of the show that's not broadcast live to meet fellow community members or to ask any questions you may have about TensorFlow JS in a non-recorded setting. Maybe you've got a project idea and you're looking for someone to hack with, come join us after to discuss, and of course for a chance to win those books we spoke about earlier. Okay, so with that, let's get the show started and meet our first presenter. In this episode, we're joined by Mohamed, who's developed a 3D MRI brain segmentation tool with his research team using TensorFlow JS that works live in the browser. First though, Mohamed, tell us more about who you are.
Hi Jason, thank you for having me on your channel today. As you said, my name is Mohammad Masood. I had my PhD degree in computer science from Georgia State University. Where I developed my research expertise at that time in the domain of image processing and machine learning. After my PhD, I joined Emory University School of Medicine as a research associate. So I extend my expertise at the time for the domain of computational pathology. Later, after that, once I joined Georgia State University, the Center of Neuroimaging and Data Science. We started to develop our BrainChop tool that can do a 3D segmentation in the browser that we will discuss today.
So that sounds amazing. Do you have a demo to help our viewers understand what's going on here?
Yes, we have a demo for brainchop.org. So you just need to type brainchop.org in the browser to load the demo. And the demo is a very simple interface, as you can see. So we have on the left hand a viewer that can show the original MRI data, and in the right hand we have the segmentation result. And the segmentation result here actually is showing us a very simple task in neuroimaging, which is gray matter, white matter segmentation result. So the gray matter actually, as we can see here, is the original, is the outer region in the brain, and this region actually have like a function that it can process the information in the brain. And the white matter in the middle here actually is a region that is rich and have a high density of nerve fibers, which are actually responsible for the communication between the gray matter regions. So if we want to take or see our tool in action, we can actually browse and select our Nifty file, and in our Nifty file format now we can actually doing some process on the raw data that we have now in the browser. So we have a list of models that we can select one of them. So we have like 3 main tasks here, 2 for the brain extraction and brain masking, and 1 for the brain segmentation for the gray matter and white matter. So if we run now, we will select the right one to see it and run the model. Or the inference. Here we can see actually it have a good speed in this machine, which is actually its average machine. And we actually have the 3 stages now. We have a pre-processing stage that we need to normalize the MRI in this stage, and then we feed it to the inference model. And then after the inference model, we're doing like a post-processing stage that we remove any noisy regions from the outputs. And we can, it will come now with the results. These results actually it take maybe from 25 to 30 seconds on this machine to come out. And we have also the option to save our if we satisfy with this result, we can actually compare between both, and we can see here both
wow,
of them actually have a good, it have a good.
And now you're able to go through the brain different layers, I guess, and in real time segment.
Exactly.
Yeah, very nice.
So you can see the segmentation accuracy in this case, and you can save the results if you're satisfied with them.
Very cool. That's awesome. So I'm curious to find out a bit more about the end users of your system here and what they might use this tool for.
Yeah, this is actually a great question, Jason. So actually, we make this tool very simple in order to make our end user, which they can be like a professional doctors or a medical professional in general, that they maybe don't want to go so deep with the machine learning and this stuff. They just need a simple interface to see how the results can be come out from the accuracy of the models, and then they can decide if they can actually go in more details about our tool and how they can actually collaborate with us in the future to make actually their research actually have more insights using our deep learning models.
That's awesome. Now, you mentioned there are a number of models that you're using. I'm just wondering, are these custom models that you've made and then converted to run in JavaScript via Tensorflow Js, or are these off-the-shelf models? Maybe you can just explain those a little bit more too.
Yeah, so actually, if we look in the overview of our print shop architecture here, we can see that we can actually take our model that is trained in a framework like PyTorch or Keras TensorFlow, and then we convert it to TensorFlow JS and then use it in our model. So this is actually the process that we started at the beginning, but there is something that is very vital here, important, that the lighter the model, the important that the browser can be work properly when we make the inference step. So what we need actually to do here, we need actually to align for a framework or a architecture that is light in the beginning. We have actually what we call meshnet architecture. So the meshnet architecture actually is a very light deep learning model that can actually used in the segmentation in our browser here, and it have a very competitive result actually comparing to UNet. So actually, when we compare between both in the accuracy, we can find that meshnet have a very competitive accuracy. It for this task, gray matter, white matter, the model can achieve like 0.956 micro dice in the browser in the output. And for the UNet, actually, the difference is not that far between both of them. It's only 0.006 microdice, which is very small value, but the big advantage of meshnet here actually is the speed. It's 9 times faster than UNet, and the size also of meshnet here is very small. Actually, it is maybe less than 1 megabyte compared to 288 megabyte for UNet. So actually, this is actually make UNet actually is very hard or maybe challenging to use it in the browser. It have a very high probability that it can fail in the browser. It will end the browser failing or freezing or cannot respond anymore.
Now, this is a pretty niche area, but if viewers want to try this out for themselves, where can they go?
Yeah, so actually PrintShop is a free license and open source code that is available in GitHub. We give also more explanation. I'm sharing now our GitHub repo for the project. As you can see that we give here more actually explanation in the wiki part. So the end user, once they come to this page, actually they can find how actually they can load their model, how actually they can do their normalization stuff, and how actually they check their performance, or what is the system requirement that can make this application or this tool work in their browser. And
Jolly good.
it's important actually to mention also that PrintShop actually have a funding from the NIH. We have a grant that supports these projects, and these projects actually come under the No Brainer project, which is the father project of this tool. And we will put all the links that actually can take our user to the demo and the GitHub in the description
Perfect.
section.
Wonderful. Yes. So do check that out. We'll put those links in the description after the show, and click those links and find out more information. This is really amazing work. I'm curious to know your thoughts on where this might go in the future, maybe.
So yeah, I guess our next step here will be to extend the model zoo that we have, and we can increase also the number of segmentation regions in the brain. So we have more insights into the brain in this case. We saw actually there is a potential for Tensorflow Js to perform such a type of tasks in the browser, and we believe there is nothing actually can prevent applying this amazing machine learning library into another also big medical images, such as histopathology images or microscopy high resolution images. So yeah, I guess making machine learning available in the browser that actually can make on the user side can actually enhance the browser or the application, the machine learning application scalability and the privacy,
Sure.
shareability, and also it can make it actually more popular with time.
Yeah. That's really interesting actually, because I've seen those. Obviously, this might not be medical grade, but I've seen people like experiment with like USB microscopes they can connect to the computer, and then you could analyze like blood samples or whatever it might be, and kind of get real time segmentation coming back or something along those lines, or object detection even for things you're trying to find in those samples. So lots of potential here for sure. Now, do let us know in the comments below how you might use tools like this in your industries in the future. I'm sure things like 3D segmentation could be useful beyond just the medical industry too. And with that, thanks Mohamed for joining the show, and I look forward to seeing this project grow. Wow, what a great demo there by Mohamed. And let us not forget that often the demos you see here can be applied to other industries too. 3D segmentation, after all, is not just limited to the medical field. Now, for those watching, how could you use a model like this for an idea that you have? Let us know in the comments. Also, remember, if you've got any questions for the presenters, feel free to type in a live chat whilst they're here during the rest of the show, or just send some emojis to show your love. But now it's time for me to head on to our next presenter. So today we're joined by Ian, who put himself inside a video game and even brought a backpack to life using Tensorflow.js. First though, Ian, tell us more about your background and who you are.
Thanks, Jason. My name's Ian Charnas. My day job is running an innovation and makerspace center here at Case Western Reserve University called Sears ThinkBox. And then nights and weekends, I don a secret identity where I am making content on YouTube. Generally, I make a kind of a goofy, fun, zany invention, and then I will raffle it off, and the proceeds go to charities that I care about.
Love it. That's really cool. And what exactly did you create this time?
I've got two projects we're going to show off here. One is a video game where you actually put yourself inside the video game. Instead of controlling it with a controller, you're going to control it by moving your body, thanks to MoveNet. And the second one, we're going to see an animatronic talking backpack that uses face mesh. And it was sort of a comedian in the wild experiment that respected social distancing. So we have a talking backpack powered by a comedian sitting on a park bench talking to passersby.
Amazing. I'm looking forward to seeing that. So I think, it's definitely time to see some demos. Can you walk us through those?
Yes, definitely. Let's start with the Punch Out. So this is a video game I used to love playing as a child called Mike Tyson's Punch-Out. This is Mike Tyson. He was impossible to beat. I didn't know anyone who had beaten him. But as you can see, on the right on my screen, I've got a webcam open and MoveNet is tracking my body. And it's allowing me to control my character, Mac, in the little blue shorts over there, just by moving my body. So it ends up being a really exciting way to play the game, and also quite a bit of exercise. You can see me wearing a sweatband there. It's not for show.
I'm sure the debugging was quite fun there. You got a good workout. Awesome. And I believe you're using MoveNet to power this, right? You mentioned that very briefly earlier.
Yeah. So I'm using MoveNet to track it, and you can actually see the results of MoveNet in the little skeleton that's superimposed on my body. And it was really interesting to try to think about what the moves would be. So this video game, thankfully, was made in a simpler era where controllers had a relatively simple number of buttons. The NES, the Nintendo Entertainment System control pad had really 2 or 3 buttons that are used in this game. There's A, B, and Start, which is great for this kind of game because a game that has 50 different moves would be hard to control with your body. Now, one of the interesting details was that MoveNet, as amazing as it is, doesn't have a way to process depth. It can't know whether I'm punching towards the camera. So I couldn't use this as a way to track the punches. Instead, if you take a close look, you'll notice that when I punch off to the right or the left, my little character, Mac, is going to punch forward. This is the move that you perform in order to get Mac to do the punches you want in the game. There's also duck, the star punch, if you remember that, those of you who have played this on Wii or any of the other systems that have had Punch-Out. So it's really interesting to think about what movements of the body are going to translate to what movements in the video game.
Now, if I remember correctly, you kind of leveled things up a little bit here by introducing some electric shocks. Maybe tell us more about that one.
It's true. It's true. So every time I play a video game, I always feel like this character on the screen is getting hurt and nothing's happening to me, which is usually what you want to have happen. I don't want like a fireball blown into my face like you see in Street Fighter. But a question came up. Would you be a better player if there were stakes? If something actually did happen to you when your character got hit in the game? What I decided to do was to make a small electric shocking armband to deliver an electric shock to me anytime my character gets hit on the screen. And the way this works is I've taken out the little shocking mechanism from a kid's electric joy buzzer. So something that gives you a little shock, but we know to be generally safe. I didn't attach a taser to my neck or something wild like that. And it really does matter. When I put this on, I've never been so alert in a video game in my life. And I really did perform better.
I would be much more worried about losing the game there for sure. So.
Yeah, even one hit you want to avoid.
So that's really cool. Is there a link people can try this out for themselves?
Yes, you can actually play Real Life Punch-Out for free by visiting reallifepunchout.com. And all it takes is a computer with a web browser. You don't need a Nintendo. You don't need a Wii. There's no fees, anything like that. I will suggest that you watch the tutorial video that's on that site before you just jump in and try to play the game, because you need to know what the movements are, the ways to move your body to get your character to move in the game. Guessing is not going to get you there, so watch that tutorial before you play.
Excellent. All right, so let's move on to the backpack, and how do you make that one?
So this project is an animatronic talking backpack that's powered by Face Mesh. I'll just show you this little intro here. This is the introduction from one of my YouTube videos. Get out your 2020 Apocalypse Bingo cards. Who had talking backpack? So let me start to show you how this thing works. This is really cool. This talking backpack is remote controlled, and it's actually remote controlled thanks to Face Mesh. So let me show you a little screen share here. For anyone not familiar with Face Mesh, it does what you see. It puts all these tracking points on a face, and it can track it with and without glasses. It has an incredibly high frame rate, even in JavaScript and even in browser. So wouldn't it be great if you could use this technology to control animatronics so that instead of complicated controls, you could just speak and emote with your face in the normal way that you do, and the animatronics would mimic your movements. So this is what's inside that backpack. This is the animatronics. We're seeing the business side. You see the eyebrows, which move, and you see the mouth, which moves. And then on the right, you can see my laptop with Tensorflow Js running face mesh, and you'll see me controlling the mouth and the eyebrows.
That's so cool. I love seeing people combine things with hardware with TensorFlow JS, because I think sometimes JavaScript devs forget that it's actually possible. How do you communicate with it? Is it Bluetooth or something like that, or Wi-Fi?
Ah, great question. Great question. Yeah. So it's an especially good question because I wanted to place a comedian in a park such that you couldn't see her. And the backpack is sitting on a bench, so it had to be wireless. So once I had this working, I had the idea to put this inside a park on a park bench, which you're going to see in just a second here, and have it be remotely controlled by a comedian. So here's this being installed in the park. You see there's no wires. There's kind of an obvious camera behind it, but that's how we did it. This is the park I installed this in Cleveland. There's a comedian. She is sitting next to the laptop, and whatever face movements she makes are recognized by the in-browser TensorFlow JS running face mesh. And then inside the browser, in order to connect this to hardware remotely, I have the browser talking over a serial port. Actually, at this moment, I'm blanking on whether I used Web USB or Web Serial. Those are two different options. So that I can send serial commands to an Arduino, which had a wireless link to an Arduino that's actually inside the backpack. And that Arduino was responsible for controlling the movements of the servo and stepper motors so that the animatronics would then move. That was the flow of information on that.
I'm just curious, have you considered using Web Bluetooth Low Energy or something like that as well? Was that not suitable for this? Was it not high enough bandwidth or something like that?
Yeah, the Bluetooth options for JavaScript are pretty robust and solid. However, this was at an outdoor location with a lot of trees in the way, and trees can sometimes absorb RF energy. And I wanted to have the comedian so far away that all you saw when you're walking through the park was the talking backpack. So she's over 200 feet away. So I needed a pretty high power transmitter, and I just wasn't confident Bluetooth would do it.
Fair enough. Thank you. That's a great answer. So the other thing at this point is how easy was it to kind of hook up face mesh to this backpack? Obviously, this is like a physical piece of hardware, and face mesh has like, I think, 384 little key points there. Was it pretty much, grab a few key points and then, attach it to a servo, or was there some more work involved there?
Yeah, that's what I love about these models that have been trained for TensorFlow, is that they make the part that I, the developer, think is going to be the hard part. They make that the easy part. It took me one day to write some JavaScript code that used TensorFlow JS and face mesh to draw the tracking dots on my lips and my eyebrows, and then also to write a little application, a little web page with some JavaScript that could allow me to set thresholds. I need to set my brow low threshold and then set my brow raised threshold so that the later on the software can actually interpret whether my eyebrows are up or down. And same thing with the mouth. And since it's running in the browser, it's so fast, I can do all sorts of math to scale it. So I didn't have to worry about the comedian getting too close or too far from the camera and changing the specific XY coordinates, because I can scale and look at things relatively. So nice. I finished that code in one day. The hardware is always the hard part. That took several months.
Fair enough. Well, awesome. I mean, I know people can't really try this one out for themselves, as a backpack is very unique, but maybe there's a website to learn more about that whole process, or a GitHub repo for the code side of things. Yeah,
I include a lot of technical information in the YouTube video. And also, I hope that you want to check out the comedian talking to people in the park. It's really pretty funny. So you can visit my YouTube channel, youtube.com/Ian Charnas.
Perfect. We'll put all those links in the description after the show for people to check out. So do go check those out afterwards. So at this point, you've made a lot of great projects, and I've got to ask you, what are your plans for the future? Anything in mind for TensorFlow JS?
I actually started to work on another TensorFlow project. And this time, I don't want to use a TensorFlow trained model. I want to dig a little deeper and do something a little more challenging and challenge myself to actually dig into the guts of TensorFlow and do real AI. And without giving away exactly what it is, it's not obvious. It has something to do with the stock market. So follow me on YouTube to see that video.
Okay, that sounds very cool. I'll be tuning in for that one. So thank you so much, Ian, for being on the show today. And of course, to all the viewers watching, let us know what you think about these projects in the comments.
Thanks, Jason. Thanks, everybody. I'll see you on the internet.
Thank you so much, Ian, for that great presentation. I love it when folk use JavaScript with custom hardware and get really creative like you've done in these two awesome demos. Now, I believe Ian might be live with us in the chat here today, so if you have questions, ask them over there, or if you're joining us after, drop a comment under the video. Now it's time to head on to the next demo. Joining us on the show today, we have Mariel, who's created a really marvelous demo called Beyond Imitation that uses autoencoders for dance movement generation. First though, Mariel, please tell us a bit more about yourself.
Hi, Jason. Thanks for having me. My name is Mariel Pettee. I am a physicist. I'm currently a postdoctoral fellow at Lawrence Berkeley National Laboratory, and I'm also an artist. So I like to work with machine learning tools for diverse applications ranging from fundamental physics to the arts.
Wow, that's very cool. And I love the combination of skill sets there, like this hybrid of very nerdy physics stuff along with the more creative side as well. That's very cool. Someone of my own heart, so love it. So tell us a bit more about what you've actually created today.
Yeah, so over the past couple of years, I've worked with a couple different independent research groups to investigate the application of different machine learning tools to choreography, and in particular to my dancing body. So I have captured data of myself doing improvisational dance in a motion capture studio. And today I'm sharing some results of a generative model that we've trained to understand how my body moves and can create new movements in my same style.
So clearly there's a lot involved in this project. Did you work with other people on this as well?
Yeah, so I started on this question on my own, and then over time I started inviting colleagues in and realizing that it was so much more amplified by working with other people. So the team that I ended up assembling over the past few years consisted of other physicists who were colleagues of mine at CERN who specialized in machine learning, as well as folks from the digital humanities who were experts in data visualization and software development, as well as some of my colleagues in the dance world who think about choreography and technologies in the context of their choreography.
Wonderful. And I believe you've actually got a video of one of these people in action using the product. Can we see that?
Yeah, I'd love to share this. So this is my colleague Raymond. So he is performing in the studio, actually in the motion capture suit, and he is able to get live feedback from a trained model understanding his movements. And so you can see that in this on the screen in the bottom part of this video, where he's actually getting information from the model about where in the latent space of the model his movements lie. So he's trying to explore as much of that latent space, sort of the model's version of his movements, as possible.
Very cool. And it's great how the dancer can kind of get real-time feedback and then react to it themselves and continually move through that latent space, as you said. So very interesting. Okay, so you mentioned that you're using kind of full body motion capture to do this. Do you have any more information on that?
Yeah, so I had access to this gorgeous studio that basically had 20 motion capture cameras arranged in roughly a circle above me. And this is an image of me in the motion capture suit, which basically consists of 53 reflective dots that are all over my body. So the motion capture studio is able to see all these different points at around 35 frames per second while I'm moving.
That sounds pretty exciting. Can we see it in action?
Yeah, absolutely. So a video that I'd love to show here is a video piece that I constructed, which I call Mirror Exercise. And this is an AI-generated duet with myself. So what you're seeing here is in the figure in black is my real motion capture data from a couple data taking sessions in the studio. And in blue, you see a dancing accompaniment that is generated by the model. So in each case, the model is seeing a certain segment of my movements and is creating a slight variation on it in some sense. So I can control how how much variation or how little variation I want to see. But in each case, they have this nice relationship.
That's awesome. So it's literally responding to you in real time. And I got a question here, actually. So is this responding frame by frame, or is it taking like time into account? So like if you're doing like a hand swoop, it will also maybe do a swooping movement with the hand, or is it just analyzing each frame in the moment and then responding?
Yeah, great question. So it is getting a sense of movement. It's taking in, it analyzes about 5 seconds of movement at a time, and then it creates its own response or interpretation of that phrase.
I see. Very interesting. And of course, you mentioned that you're using autoencoders, which essentially is a special type of generative machine learning model architecture that, as we heard from Douglas on our last show, essentially consists of an encoder and a decoder. Now, can you tell us a bit more about what makes yours different to a regular autoencoder in order to do this custom model that you've made here?
Yeah, absolutely. So a typical autoencoder is trying to learn a compressed representation of your input data, and that's essentially still the same thing that we're using. But we train what's called a variational autoencoder, and that allows us to use it as a generative model. And basically the main difference is that instead of learning a single representation for every input image or input sequence, we are learning a distribution to represent each input. And so I can then sample from those distributions, and I can get a variety of different outputs as a result.
I see. So that's okay. So you can vary what the results are that you get. That's very cool. So in that case, I'm sure many people watching right now want to try this out for themselves. Is there a website they can go to actually see this in action and play with it?
Yeah, absolutely. So my colleagues and I created this website, beyondimitation.com, and it's sort of a companion piece to our paper as well as some of the videos that you just saw. So this is meant to give folks a hands-on experience playing around with this model itself. So we have a little bit of a description of what the project looks like. We link to our code. And at the bottom here, we use Tensorflow Js to see a live demonstration of the model. And so in particular, what that means is you can kind of scroll through and pick a different time frame in my movement sequence. And then you can choose how much variation you want to include on the original phrase. So if I draw this all the way down to the bottom, we see the model's best representation of this original phrase. But if I scale it up, then we would expect to get a movement that's related, but is distinctively different from that original phrase.
So how did you refine the process to actually make the duet?
Yeah, so beyond just generating new movements, we realized that there were lots of different ways that we could apply the same trained model to create some interesting results. So in particular, the model has a sense of which movements are related to one another based on how close together they are in the model's latent space. So this is a cartoon that illustrates what that means, where you might have two sequences that are the model sees as highly related, that have some shared characteristics. Maybe it's that all 4 limbs are on the floor, or maybe down here, it's something about the timing, about moving from the ground back to standing. And I can exploit this basically by looking at the model's best representation of a given sequence. And that's what I illustrate here. So in black, you see my real data. And on the far left in blue, we see the model's best representation of that output. And you can see that the model's managed to capture a lot of the important kinematic qualities of that sequence. But if instead of decoding that original point, if I add a little bit of noise to that point in the latent space and decode some new point that's close by, we get these subtle variations. For example, this rotation at the end of the sequence, or I can add even more variation and get a sequence that's even further away from that original.
Very cool. And I guess my question at this point then is, as an artist, how much noise do you add before you consider it original? I guess there's a fine line between when it's the same and versus when it's something different, right?
Yeah, I've thought of the duet. I think it goes through different moments where there are points where it seems like I am redoing the original choreographic intent that I had in the studio that day. Maybe if I could just go back in time and make a slightly different choice, it still feels like it's capturing something, the same idea. But then you're right, beyond a certain threshold, it starts to become more like two different bodies that share some kind of awareness of each other, but they're meaningfully doing different things.
That's awesome. I love that. I think people are going to have a lot of fun with this. And I've got one more question now that I'm seeing this actually. So in TensorFlow JS, we've also got a model called MediaPipe Blaze Pose 3D, which is a 3D point estimation for the human body. Would you be able to pipe that into your system to use that in the future so that users could actually have it respond to them in real time via the webcam? Or is it very tailored to the points that you had with your motion capture device?
Yeah, well, this model in particular was trained on the data set that, of course, came from my motion capture movements.
Yeah.
So that had around 50 key points on my body.
Okay, so
that
it's quite granular there. Yeah, okay. Yeah.
But that's not to say that the generic type of model that we're using, I think very similar strategies could be applied. And
nice.
it's a really cool idea, actually.
I mean, it'd be great for people to be able to try it in their own homes as well. And this is a great piece of research. And I love how you brought it to life in the browser of TensorFlow JS, which brings me on to my second question actually there. So did you train this originally in Python and then convert it to JS, or did you do the whole pipeline in JS? What kind of stack did you use?
Yeah, originally it was all trained in Python, and we exported the trained model weights and then uploaded the model to TensorFlow JS.
Awesome. And we're starting to see a lot more people do this actually. I'm always excited to see the kind of intersection of the Python world and the JS world together. And I hope more people like yourself do this in the future, because great things can happen. And of course, you can get the reach and scale of the web with the shareability and all this kind of stuff too. So I hope more research comes out in JS and gets converted over. So I look forward to seeing all of that.
Yeah, it was one of the goals of the project was to make generating choreography feel more accessible for different people. So even if you might not consider yourself a choreographer, you can still play around with movement.
Totally. Yeah, I definitely played with it for a few hours the other day. So it's been good fun. Now, I also love when creative and tech worlds kind of come together as you've done. So I'm curious, are there any plans to extend this further, or maybe new ideas you have around TensorFlow JS that you might be considering?
Yeah, absolutely. Well, I consider this to be a branch of my scientific research as well as my creative research. And next, I'm really excited to create a live performance based on some of these models. And in terms of the research as well, I am interested in scaling up to thinking about analyzing duets. So rather than just a single body, understanding how different bodies respond to one another and seeing if a model can understand those relationships.
Very cool. I look forward to seeing what you create there. So I also heard you're considering looking into graph neural networks as well. Any more details on that?
Right. So recently I was interested in applying graph neural networks to the analysis of my movements, because the previous models that I used really had no sense of the structure of my body. It was just looking at this cloud of points moving in space. So rather than focusing on only generating new movements, I was interested in moving the analysis inward to understanding the kinds of relationships that existed between parts of my body. So I worked with a group with Intel's AI labs with a couple different colleagues who helped me to basically augment the existing variational autoencoder to a graph-based variational autoencoder.
Awesome. So can we see that in action?
Yeah. So the GNN that we ended up training was designed to identify patterns in terms of the types of relationships that it noticed between different points on my body. So what you're seeing here are a couple different categories that the model has learned for the types of interactions that are happening while I'm moving. And in particular, the edge types 1, 2, and 3 represent meaningful edge types, whereas the first edge type here represents no interaction between those edges. So you might notice that, for instance, edge type 2, which is in blue, all of these connections originate from my right hand and then connect to my left foot. So the model is identifying some meaningful patterns in these cross-body connections. Or in edge type 1 here in red, all of these originate in my left hand and then connect to my upper torso. So it's super interesting to me to see what a model sees as driving my movements versus maybe my own understanding of my body's relationships while I dance.
Very cool. I look forward to seeing how that progresses.
Thank you.
And as mentioned, all the links we've described in the show will be in the description after the show, so do go check those out. And of course, consider leaving a comment if you've got ideas of how you might want to use this sort of technology in the future. So thanks, Mariel, for being on the show, and I look forward to seeing more of your work in the future.
My pleasure. Thanks for having me.
Thank you so much, Mariel, for that super creative piece. I myself have been a hybrid of the creative and tech worlds for many years, and seeing these two areas intersect is always a pleasure. I'm seeing a lot more active research within the Tensorflow Js community around autoencoders and even generative models these days, so do let me know if you make something in the space for a chance to be on a future show. And with that, let's see who's up next. So today we've got Kevin joining us, who's very active within the TensorFlow Js community and has a passion for super resolution, which we'll hear more about in just a moment. First though, Kevin, tell us more about your background.
Yeah, well, first of all, thanks so much for having me on your show, Jason. My background, I've worked a number of different fields. I spent some time working as a designer, and then I moved into doing front-end web development. I did a couple of years working as an ML engineer. And I kind of like bouncing back and forth between each discipline and also kind of finding the intersections of each one as well. Nice. is pretty exciting. I also wrote a book on using TensorFlow Js, getting started with machine learning in the browser. It's pretty short, it's 100 pages, and you can get it online.
Jolly good. A man of my own heart there. I certainly like bouncing around various different locations as well. And you've been really busy. And of course, we're going to put that link to the description of the book in the description of the video afterwards. So do check that out. Now, what exactly is super resolution, and what did you make exactly?
Super resolution is the process of taking an image and making it bigger. I think the best way, maybe the funniest way to think about it, is to think of those CSI shows where they all crowd around a monitor screen and they say, hey, zoom in on that little detail there. In a nutshell, that's what super resolution is trying to do. You're trying to take an image at a certain resolution and get it as close to the original image as you can. The tool that I built is an open source library that accomplishes that using JavaScript. So it's a library for taking in images and running it through a neural net that does the super resolution and then displaying it on the other side.
Very cool. Literally bringing sci-fi right to us. Very, very interesting. So I think it's probably time to see a demo. Do you have one for us?
I sure do. This is Upscaler.ai. This is a website that has an implementation of Upscaler running in your browser. And so what you can do here is upload an image by clicking that button or dragging and dropping. You can also click one of the images below if you want. So
you can see there already, this flower seems to be, literally enhanced. You can see all the detail in the petal veins there and the pollen. If we just zoom out a bit here, because obviously it zoomed in at the end, you can see that effect magnified even more, the before and after there, which is really beautiful, stunning stuff. And yeah, let's try some of the other images down below. Let's refresh this page and try again here. So we've got some pre-made ones. Let's try this lady here. And again, you can see here, very fast, worked almost in real time. And but the details in the lines behind her face and the shadows on her eyes and neck, it's like night and day, really. So really amazing stuff. I'm going to go ahead and fiddle with a few more just for good measure. And yeah, here you can see, again, it's working really well here. The clarity in the hair and the details is much better than before. And if I zoom out on this one, in fact, just to kind of make it a more realistic size, the effect is magnified even more, but it's like, completely different between the two there. And I know which one I would use on my website for sure. Very good. Now, when I was using this tool, I noticed at the top here, we've got this drop down for GANs 4x, div 2k 4x, and all this kind of other options. What's all that about?
So the tool allows you to choose from a number of different models. Models can be trained on specific data sets. They can also use different architectures. So you might want to choose a model that's faster but less performant versus one that's beefier and is more accurate but takes longer. The other key thing there is that specific models are tied to scale. And so depending on the size of the image that you want to produce, a 2x model is different than a 4x model. And so you need to decide that up front.
And just out of curiosity, are the inputs fixed for these models, or can you have variable sized images as inputs?
Variable size images. They can be any format
Wonderful.
that you want.
Oh, excellent.
Or I
That's
should
very
say
good to know.
any size that you want, any aspect ratio.
Perfect. So this like div 2k4x, let's maybe try that and just see the difference between the two models maybe and just see how that goes.
Sure.
Cool. So similar speed, so that's good, both pretty fast, but you can see here, this is definitely more of a painted kind of look than the other one, right? This is actually more like a painting. So maybe it's due to the training data that model was trained on and so on and so forth, as we discussed earlier. But, you know, it's good to play around with this and see which one works best for your image types that you're using, I guess. So that's very interesting. Awesome. So why would one want to do this in TensorFlow JS instead of backend on the Python? Any thoughts on that?
Yeah, I think that there are a number of really compelling reasons to do this in JavaScript. One is privacy. Being able to upscale an image right in the browser where you don't have to upload the image to some random server and have your data out there, I think is really compelling. Another really, I think, compelling use case is around latency and not having to wait for the response from the server. That said, I mean, sometimes a server-based implementation of this technology might be faster, but particularly for users who might be on like slower connections or something like that, just being able to do it directly on the browser, I think, is very compelling. The other, I think, really interesting use case that was very compelling for me was the idea that you could save on bandwidth by sending these lower resolution images down in the initial payload and then upscale them right on the client.
Right, definitely.
And especially if it's at lower sizes like 2x, where some of that artifacting isn't quite as noticeable, I think that's really compelling from an infrastructure standpoint. And
definitely.
You know,
in fact, you just reminded me of a great case study we just launched with LinkedIn over on our blog on TensorFlow. They trained a machine learning model to understand the network performance and the mobile device that's requesting the certain images. And in real time, they'll replace the images with a high resolution or a low resolution one. But of course, as technology like this progresses, you can actually do that all in the browser as you're scrolling down to view the image. It would enhance it in that moment in potentially real time in the future. And you can actually do that instead, which would be very interesting for larger companies who are dealing with like terabytes of image data going through the pipes every second, right? So that could save them a lot of bandwidth.
That's fascinating. One of the things that kind of caught me off guard when I released this library is that a lot of people asked for Node.js support, which is not something that it supported out of the box. And it took me kind of by surprise because a lot of the use cases I had in mind were around running it in the browser, and yet there was a lot of demand for it on the server. I think largely to maintain that parity between client-side code and server-side code, I pushed out a release that added explicit Node support, and that's something I'm very interested in continuing to explore.
Very cool. Very nice. I look forward to seeing where that goes. And of course, in this case, you took a model that started life in Python, right? And then you retrained it and converted it to run in JS in the browser. Maybe you can tell us a bit more about how your flow worked there.
Yeah, absolutely. So I think the first thing is to find an appropriate architecture, which is not as, so in Python, it's often going and looking at the benchmarks and seeing what's number one, and that's the one we're going to use. With this particular use case, performance is not performance of the upscaled image is not necessarily number one. It's also how fast does it run. So I think the first step is finding architectures that are that take that into consideration. So I ended up using this architecture called ESRGAN, and I found a very good implementation of it that was written in Python, written in Keras, and so I was able to port that over to the JavaScript. I used the TensorFlow JS converter to do that. It's quantized very heavily. I did some specific training. Some of the pre-trained models that the original Python implementation offered were focused on a backend implementation. So they expected that they had some beefy hardware. I was able to shrink some of the architectures, which does impact performance, but it's sort of a trade-off. And so,
and did you do that shrinking manually yourself, or is that something you could do with the converter, or how did that happen?
That's that's something that I did myself.
Cool.
Because that's a matter of changing the actual architecture of the model. So, for instance, how many layers deep does it go?
Right. That makes sense.
And the other thing that I'm very interested in exploring is weight pruning, which I know there's very good support for that in TensorFlow, and that's something that I think could add some big speed ups. Weight pruning is finding neurons that are sort of underperforming and just kind of snipping them,
just getting rid of them,
snipping them out of the snipping out.
And of course, that's going to help with the model file size to get it delivered to the client side as fast as possible as well. Then
exactly, right,
very useful,
and speed up how fast it's processing those images.
Exactly, all of the above. So it's a win-win for everything. Jolly good. Cool. Well, now seeing is believing. So do you have any links for our viewers to try this for themselves or read more to go into more details?
Absolutely. So I recommend viewers get started on that site, Upscaler AI, the demo. From there, you can check out the repository itself if you are technically minded and want to play with the code yourself. There's a link in the top right of Upscaler AI that'll take you right to the GitHub repo. On there are a number of examples that will run code right in your browser, and you can edit it and see how it's working. And that's a really great way to get started with the tool. If you're interested in even more, I have a great blog post that I'll share with you that goes deep into depth about how I developed this and some of the challenges I ran into.
Yeah, I'm sure people will love to read that. And we'll put all those links in the description after the show, of course. And, I love it when folk like yourselves produce these libraries like Upscaler.js, which everyone can use, right? So it's really, really beneficial for all. So maybe I'm going to try an image that it's never seen before, one of me wing walking. Let's see how that goes. So let's upload myself here. And you can see it processing there. And boom, here we go. So now it seems it's kind of created a almost painting-like effect. If I zoom out a bit, it's like a little bit better, I believe. So here you can see it's definitely more sharper, and it's definitely an image I'd prefer to use over the original. But of course, when we zoom in, we can see kind of almost the inner workings of the model to some degree of what's going on there. Can you explain that a bit to us? What's going on?
Yeah, absolutely. The what you describe as the painterly effect is it's definitely something that these models, a lot of these models do, and it's largely because the models are they're not recovering pixels that were somehow missing from the image. They're actually generating brand new pixels. There's a few ways to improve that. One is bigger models, so just more performant, beefier models, but those will take longer to run in your browser. Another way to improve that is potentially different architectures. So, for instance, using one of the interesting, I think, areas of research is using the features that the image produces that a network that like VGG might identify as input to the training. And then a third one might be training on specific data sets. For instance, training a model specifically on art or illustration, or in your case, maybe training a data set on a data set of JSONs might get you really good performance.
Interesting. So yeah, that makes sense. You want to kind of customize those models to be targeting the types of data you're going to be working with in the real world to have the best output performance.
Absolutely.
Yeah. Cool. Awesome. Now, I'm curious what's next in your TensorFlow JS adventures. Maybe if there's like one library you could make that you've not yet made, what do you think would be a good fit for the future?
That's a great question. I think I've been so heads down with trying to get this library out the door. Part of me is interested in just kind of going back and adopting beginner's mind again and seeing, one of the fun things and also frustrating things about this field is how fast it changes. And so,
yes,
even I think in the year or two since I started working on this, so much new stuff has come out. And so just taking taking a breath and, learning some of the new things that have come out is really exciting. But more specifically, I'm always interested in the intersection of things. So the intersection of design and AI, the intersection of art and AI. I'm a musician, so I'm really interested in how we can connect AI to music.
Very cool. Yeah.
So something there. I'm not sure exactly what, but I'm going to see where the curiosity goes.
Yeah, we have Magenta.js, which is powered by Tensorflow Js behind the scenes, actually, for more creative applications of AI, such as music generation and all this good stuff. And for those of you who are watching right now, you might want to check out the tone transfer demo for Magenta.js as well, which allows you to convert your voice into a musical instrument of your choice, which is pretty cool. That's live on their website somewhere as a demo. So many great things can happen when you put your mind to it. Awesome. Well, thank you so much for being with us today. And of course, if anyone's got comments for Kevin, do leave them in the video after the show. And thank you for being on the show, Kevin.
Thank you so much for having me. This has been a blast.
Wow, that's some powerful stuff right there. Imagine a world where models like this are refined to a point where you could send highly compressed images to the browser and then lazily enhance images as you scroll in real time in JavaScript. Now, I'm sure with time, such things may indeed be possible, and we saw the start of it right here from Kevin. So a huge thank you for that. Now, if you've got questions about what you just saw, do leave a message, and remember, if you're enjoying the show so far, hit those like and subscribe buttons to be notified of future shows. We do this every 3 months. Okay, now onwards we go to our next presenter. Today we have Benjamin, who's developed his very own hand tracking engine with Tensorflow Js. So Benjamin, tell us a bit more about who you are.
Sure, thank you for having me, Jason. So I'm a software engineer based in Zurich, and I have worked in the past with both web development and machine learning quite a bit. And so TensorFlow JS is really exciting to me because it sits at this intersection of the both of the two. And so in the past I've worked a lot of on a lot of problems regarding machine learning, mostly related to text. And now I had this opportunity to explore a vision-related task with my recent project, and that was quite a good learning experience.
Perfect. So what exactly did you create here?
Yeah, so it's a hand tracking engine called YOHA, and so what it does is it processes the video feed of your webcam, and it detects the location of your hand in this video feed. And the goal of it is that it allows you to quickly sketch something roughly similar to how you would do it on a whiteboard. And this is also what was my initial inspiration for creating this, because when the pandemic hit us and forced us into home office, I really felt that this on-premise whiteboarding-like experience was something that I missed, and so I tried to create something that resembles that.
That's very cool, and a very nice motivation for it as well. So maybe we can see a demo of this in action.
Yeah, sure. So if you head over to handtracking.io/draw_demo, there you have a small example of how to apply this and draw some sketches with it.
Okay, so here it is. How do I get started?
Yeah, so first, if you raise your hand, it should detect that it is there and draw some lines on it. Perfect. And now you can close your index finger and thumb, and then it should start drawing, and then you can draw some sketches.
Lovely, and there we go. And that's working pretty well.
Nice.
Amazing. But yeah, as soon as I let go, it stops. It's perfect. Let's try and do a smiley face, maybe. Clear it, I think, like this. That's right. There we go. It's so dot, and a line, and another line. Beautiful. There we go.
Awesome. Yeah, looks good. So it detects 21 locations on your hand, and it also detects two classes, sort of. So it detects if you do a pose, like the fist, and the pinch gesture for the drawing. Yeah.
We'll take it. Yeah. Now, it seems you made a custom model to do this, right? It's not using our pre-made hand pose model that comes in TensorFlow JS.
Exactly. So as I previously mentioned, the original idea was to enable these kind of drawing-like applications. And so when I started out, I looked for what I could use. So if there's something already out there, and I stumbled upon the model that you mentioned, and it's a great model. The reason why I decided to create my own one was twofold. So one is it had to be optimized for these kind of pinching gestures. And the other one is that, at least back in the day, so the TensorFlow model also got a lot better since, but back in the day, I felt that the quality was a bit lacking for these kinds of hand poses.
Sure, yeah, I remember the first version was it was a little bit stuttery,
yes.
But yeah, definitely good stuff.
Yes, in particular this pinch pose. So if you think about how can we detect it, there's a common approach where you take the coordinates that one of the neural networks predicts, and you feed these coordinates into another neural network that then acts as a classifier that says, now these coordinates correspond to a pinch pose or not. And this is a very valid approach. It has pros and cons. And one of the cons, though, is that while the coordinates say something about the hand pose, they do not encode necessarily a lot of information about the volumetric information about the hand. So you can have two hands that have a different volumetric shape, so to speak,
Sure.
and they are corresponding to identical coordinates, and that makes it hard for detecting whether your fingers are really together as soon as they're close together. So if I have a pinch pose like this where the fingers are really close but they're actually not touching, this presents a limitation. And so one crucial difference in my model is also that I actually have simultaneous prediction of coordinates and classifiers, and that allows the classifier part also to actually observe the whole frame and maybe learn that actually the skin of the, say, thumb and index finger, as it's the case in YOHA, actually touch or not, which would not be possible or not that well possible with the other approach.
The hand pose one. Interesting. That's very, very cool. And I'm curious there, for the training data to train a whole new model from scratch, was there some open sourced kind of repository of images, or did you have to do this all by yourself?
So it's the answer is I maybe didn't have to do it all by myself. This is hard to answer because you never know what you might have missed out of. Maybe there's a great data set that I missed out upon, but I decided to create my own data set, and this was actually a tricky part indeed. So I started out by just creating a small one first with just data from me, which of course worked well for me, but not for other people, right? And then I expanded sort of the breadth of the data set to friends and family. And afterwards, I even went one step further and collected some data using crowdsourcing.
Oh, wow. That's very cool. And did you have like some kind of pipeline to annotate, or was that manually labeled by yourself or the people who were involved?
So I had a pipeline to do the annotation, but there was no magic there. So, let's say, it was still a lot of manual. Yeah, exactly. So I tried to create tools and applied some tricks to save me some work, but still, a lot of manual work was required.
Well, it's very interesting, and the end results are really amazing. So great research there. And I guess if people want to try this for themselves, how can they get started?
Yeah, so the easiest thing is to just head over to the GitHub page. Immediately on the front page, so in the README, there's 2 examples linked, and that is a good place to get started. There's also a Slack channel where you can ask any questions. I try to check now and then if there's something new. So yeah, if there's any problems or so, just ping me there.
Perfect. So we'll put those in the description after the show so everyone can find those and go contact you. And I guess here, what's next on your to-do list for TensorFlow JS? Anything you have in mind for the future?
Yeah, so if time permits, I would love to expand YOHA a bit further. So for example, adding more gestures, maybe even some that include the temporal dimension, because right now it's just based on individual frames. There's no gesture detection that would involve several frames. So there are a lot of opportunities, and that would be my next steps.
Awesome. I look forward to seeing that. And thank you so much for being on the show today. And I look forward to seeing how this project evolves.
Yeah, thank you. And thank you for having me.
Oh. There we go. Oh, I don't know what I did there. Whoop, that's my cane. Okay. That's a baseball cap. There we go.
Here.
Beautiful. Capture that one, Eric. That's Thanks to Benjamin for that super fun demo. I certainly enjoyed playing with that one. It's also great to see folk refine and make their own models to suit their needs like you just saw here. In fact, what existing TensorFlow JS models would you like to tweak? Let me know in the comments below. Remember, our presenters are here live in the chat with us today, so do ask questions if you've got any, and now we'll head on to our next video. Welcome Joo Hyung to the show, who's working on what could be the spell check for designers using a custom TensorFlow JS model. First though, tell us more about your background.
Hello Jason, thank you for having me today. And my name is Joo Hyung, and I'm a product designer, and I'm currently working at Naver Now, which is the video and live stream platform in South Korea. And I'm very excited to have this opportunity to share one of my best projects to all of TensorFlow JS fans today. And I hope my interview will inspire someone else, just as I was inspired by this show and started my project.
That's awesome to hear. Thank you so much. Now, I mentioned a visual spell check for designers. So what exactly is it you've created and what are your goals for the project?
Thanks for the question. And I started this project last year, and I created the AI plugin for Figma and Zeppelin using TensorFlow JS. And in long term, as you mentioned, I aim to make the spell check for designer. And I prepared my screen, and so let's get started to share my screen and have some demo.
Sounds good. Yeah, I'd love to see a demo. Let's see that in action.
In this example, we have three checkpoints on screen number 1, as you can see. 1, 2, 3. And as we move on to the next screen, we'll see the screen number 2 has 2 more checkpoints, 3 and 4. So if we look into those 2 new checkpoints, we can recognize that they are detached instances, which means that they are probably misdesigned. So that is the designer's spell check, and that is the Figma ML that I can make using the TensorFlow JS. Basically, this is a plugin for Figma and Zeppelin, and which can recognize key elements of user interface by using the object detection API of TensorFlow, and then compare those detected objects to the design system library from Figma, and to ensure they meet the style guide of the company.
So what inspired you to make this project then?
Yeah, the usual problem with this project just stems from my design system experience. So design system is a complete set of standards that are intended to manage design at scale using reusable UI components and UX patterns. So I'm sure that most of subscribers who watch this live stream might be familiar with many design systems, for example, Google Material Design. So these days, design system is extremely common when it comes to create a new user interface for large-scale products and services to ensure their consistency and productivity. However, it still has major obstacles. One of which is increasing complexity with the increasing number of components and patterns that included in the same library and same design system. And another important thing is that it's super difficult to replace UI components one by one in the regular design file. So because of those kind of the complexity, even if designers shape the same screens just like this one used the library exactly, but another one has a legacy or detached instance. And some of them even had just emoji or Unicode or whatever, something like that the designers use. So it's true story. So they look similar, but at the same time, they are completely different in the design system's point of view. So when I work in design system teams, we work super hard to prevent this kind of the human mistake. For example, we updated design guides and feeds frequently. We did design QA very often. So, and we even published the cartoon manual, Japanese style cartoon manual to make my designers easy to understand what is the design system or what is kind of thing that they should use. But we all know that the human resources were always limited, so we think differently. We should think differently. That is the point that I started thinking about how to solve this problem by using TensorFlow. And that is the point that I met the TensorFlow Js show and tell show and inspired many kinds of things from that show. So
Awesome.
So because we have been living with many services using cool technology, for example, TensorFlow JS and face recognition and mask detection, or for example, so if we can integrate that technology into our design work, for example, a computer runs a number of the design elements instead of a human, and spell check, and autonomously recommend the design grammar to human if it finds something that does not conform to the guideline. I felt this will not only be convenient for the design system user, but also reduce the tons of burden on people like me who should man this system. So after I point out this idea, I started to make it with TensorFlow JS.
Awesome. And I'm sure many of these design specs are quite complicated as well. So it's good to have some level of automation to help you check all of those requirements as a designer, right?
Yeah, exactly.
So I'm curious, maybe you mentioned using TensorFlow there behind the scenes to make this work. Can you give some more details on how that works?
So there are a lot of challenges that I have to solve to make it work. Much larger UI data set and more optimized ML model. And finally, I have to find the best way to make my designers use this AI power seamlessly in their design process. So since last year, I have been solving this kind of problem one by one. So for data, I met a Singaporean-based startup called Mobin, and they have over 50,000 high-quality mobile screenshots for product designers. So I contacted them and presented my project just like this, and got over 10,000 high-quality UI screenshot data from there. Moreover, I received a free data labeling support from Korean startup called Select Star. We worked super hard together and annotated over 50,000 bounding box, UI bounding boxes together. I'm super and sincerely appreciated the contributions of those two companies to this project. We're still in a good relationship.
Excellent. And of course, the quality of the end model is down to the good quality training data with all the annotations and bounding boxes labeled correctly, right? So this is very worthy work to be doing at this point.
Exactly. I'm super lucky to have this opportunity to work together with two companies. And after I prepared my data set, next step was creating the TensorFlow model. I set up the Google Column notebook just like this and uploaded the data set that I prepared. And next, I downloaded some pre-trained object detection model from the TensorFlow Hub and transfer running and fine-tuning so that the model could detect the UI object. So I tested many different types of the model, and after several experiments, I decided to model and fine-tuning method that should up for my project. In this example, I used the mobile v2 and training step and fine-tuning method is just like that. And I also, the result is just like this. Here is an example of music app, and as you can see, those blue sky blue boxes are accurately highlighting UI objects right from the web browser immediately. So all of my experiments were uploaded on GitHub. So if anyone who wants to see more details, please find this GitHub repository and be my guest.
Definitely. We'll put all the links in the description after the show for people to check out. And of course, if people have any questions, feel free to leave those in the comments as well. We always look forward to seeing what people think about these projects that are on the show. Now, you mentioned that you explored using your current design system, but I guess this same principle could be applied to other design systems like material design, or maybe some custom one that another company might have. So one could just retrain this with their own custom data to then be able to recognize those components and do something similar for those things that they care about, right?
Mm-hmm.
Amazing. So where do you see this in 5 years? And maybe if there's people watching who want to get involved, what areas do you need help with right now?
I received a lot of user feedback as I released this prototype. And right now, I'm currently striving to improve detection accuracy. And I'm also interested in adding the customizer feature for detect the user's design system. For example, right now this model is just focused on the design system that I made, but if they wanted to customize this model to their design system, so I will provide some customizer feature for that kind of thing that I prepared right now. Finally, I'm trying to upgrade this plugin so that we can link our style and UX patterns beyond just discovering UI. So that is the thing that I currently have in mind to upgrade this plugin. And
awesome.
Again, it's fully open source, and there are so much room for improvement. So I'm really looking forward to the Tensorflow Js folks watching this live stream get involved in my project and give the hand.
Excellent. That's a great answer. And I hope people do get involved. It's always great to see the community come together for projects like this. And of course, for those of you watching, let us know in the comments how you might use something like this in your industry. Often a project in one area can be reused in others too. So get your creative hats on. So yeah, thanks for sharing your work with us today and for being on the show.
Thank you for having me today, and thank you for giving me an opportunity to share my project. And very unforgettable memory for me. So thank you.
Thank you so much, Joo, for showcasing your research there. I know folk from the Figma community are particularly interested in tooling like this for designers and UX engineers alike. Often, the design community has the specs that can get pretty complex quite fast, and having what's essentially a spell check for designers is super handy. I look forward to seeing how this evolves. So with that grand finale, thank you everyone, and to our amazing presenters. Feel free to share the recording with friends who could not make it today. It's simply the same YouTube link you're on right now. And for those of you still here, we'll be opening up our private Hangout shortly for a chance to ask questions and of course to win the O'Reilly Tensorflow Js book by Grant Laborde. A reminder, links to all demos will be in the description very shortly, so look out for those. And remember to use the hashtag MadeWithTFJS on Twitter and LinkedIn if you make something cool that uses Tensorflow Js to have a chance to be featured at future events just like this show. Thank you everyone for tuning in today. 2022 has been a great year for Web ML and Tensorflow Js, and now is a great time to get involved. Do take my free edX course if you're looking to get upskilled in this area to produce next generation web apps with superpowers. I'll put a link at the chat at the end of the show. Now I'll be seeing you all in 3 months with even more great demos, so look out for the next show, and of course do subscribe and hit like so you don't miss it. And now it's time for our private hangout for those of you who wish to meet in a non-recorded setting to nerd out with fellow community members and maybe even the presenters if they're still about. Feel free to join using the link that I'll put in the live chat very shortly. Thanks for watching, and I'll see you next time.